This is just. I've been recording the lesson. Some people are watching them. I looked at one the other day. It had 9 views and a like, and I was like, who's watching it? I bet it's one of the Sandrianas because they're just like the sweetest people in the entire world. Yeah, because they're like, that's what I'm recording on.
Probably
All right, so there's no notes check today, just notes. I just need your attention for a little bit. These notes are also super easy. As we move into Unit 7, I will say, this unit, for those of you who did learn it last year, I heard one of the ABC just didn't get to it. I think because Marcy might not have. Don't worry, I taught this from scratch last year because this was the stuff that got shoved out of the curriculum in 2020. And it's not that bad to learn from scratch. Honestly, I think it makes the unit make more sense. This is all about area and volume. So we're going to be finding today the area between two curves, but also volume by cross sections next time. And then we're going to start rotating stuff. It's going to be super cool. So this unit, in a couple of words, is just, in my opinion, visually stunning. You look really smart while you're doing it, so that's pretty fun. Also, because a lot of the integrals that we'll be doing are going to get a little complicated, we're going to kind of take the nitty-gritty of all the integrating off our plates, and we're going to be doing a lot of questions under the directions use your calculator, or the directions maybe set up an integral but don't evaluate it. So this is definitely more about the setup than it is about actually doing an integral, which is nice because we've been doing a lot of integrals. So this will be a little bit more fun. All right, let's teach the basics of this integral to you, or this set of notes to you in about 2 seconds. Is it like the new lemony one? Oh, how sweet. All right. So I'm going to label this picture the same way each time. My goal for today is to find this area, the area between two curves. All right, we have not done this before yet this year, but let me compare to 2 things we have done this year. We have found area between a curve and the x-axis. What calculus thing did we use to find area between a curve and the x-axis? Yeah, you've been doing integrals to find area, yes? So I would argue this blue space, that blue area, I could find by doing the integral from a to b of f of x dx. Do you agree? Don't say sure if you don't mean it. Math is not a place to be wishy-washy. All right, and I could find this area, right, underneath g of x. How could I do that? What would I integrate? What would my bounds be? And I would integrate g of x, right? All right, how could I use those 2 integrals to find the green thing? Wow, you learned all of the notes for today. Yeah, this section is really easy. So I'm going to give you guys a couple of ways to write this and a little bit of verbiage that's going to be pretty consistent throughout the unit. So I can just subtract these 2 outside the integral. That's perfectly fine. I'm going to write it a different way in the blank below, because oftentimes we're going to actually take that, the difference, the subtraction of those 2 integrals, and make it the integral of the subtraction. So I am usually going to do from a to b of f of x minus g of x inside the integral. What that f of x minus g of x is finding for us is essentially the vertical distance between these 2 curves. So it's almost like we're making a new function whose height is the vertical distance between the 2 curves. I'm going to use very consistent language throughout the entirety of Unit 7 because we're often going to be subtracting a function that is higher from a function that is lower. So I will usually call that the top function minus the bottom function, where top refers to like vertically higher and then bottom vertically lower. We'll also talk about what that means if I'm looking left and right as well, but this language gets thrown around a lot and it's pretty consistent. Yeah. Exactly. All right, so we're going to do some of these questions. I think we're going to integrate maybe 2 of them today by hand just to practice a little bit and review our trig, but nothing's going to go super crazy. So one thing I'm definitely going to do in most of these questions is graph a lot so that I can find a picture of these functions. Shall we get some calculators so we can graph? Does anyone want to grab a calculator with me? If you need one, you can go back behind where Matt and Emery sit. You're more than welcome to grab one. Hey, Nate.
Hello. How are you?
Everyone, Nate's here.
Hi.
I was gonna say I don't know how good the mic is, so.
We missed Nate on the lame joke.
I know. Where was the lame joke today? Did they do one today?
They did, but it wasn't like executed as well as it is when
Yeah, my favorite part is when he like pops out of the side. I want to facilitate him popping out of the top. I think that would be
like the side.
amazing. All right, so while I'm getting my calculator up, what I would love for you guys to do, I want you to figure out a way in y equals to plug in secant squared. Hint, there's not a secant button, so you got to get a little creative. And then in y2, I want you to put sine of x. I want you to also check your mode, especially if you've been to AP Physics since the last time we've been here. Make sure that mode is in radians, because degrees are for degrees.
I know how to do it.
I don't need the derivative of it. I need to plug it in. All right. Does anyone know how to plug secant squared into the calculator? Hint, there's not a secant button. I'm not able to actually type secant in.
Isn't it the identity?
It's 1 over something. Thank you, ladies in the back. 1 over cosine. So, are we ready? It doesn't sound like it. Oh, I'm using such bad like teacher stuff today. Are you ready? It doesn't sound like it. Sorry, y'all. The end of the quarter just really gets to me. All right, so that's how I'm going to type in secant squared. You do want to make sure you close your parentheses around that x. You don't want to square the x. You want to square the cosine. That's the way. I can't shove that 2 after the s like we do in notation on paper, so just FYI. Sine of x is a little bit easier. I've got that. Now, I'm going to go back to my paper, and I see x equals 0 to x equals pi over 4. That sounds like a window change to me, so I'm going to try to restrict the window of this graph so I can only see that part. That's my x min and my x max. For pi, if you haven't used it before, it's over the like power button, but it's blue, so I'm going to press second first and do pi divided by 4, and it'll calculate it for you. Now, that x min and that x max are pretty small and close together, so I'm guessing I need to zoom in the y's as well. I have no idea what the range for the y's is, so I'm just going to guess something, and I'm going to be okay if I have to go and readjust it to make my picture pretty. So this is me guessing. We'll see if my guess is right. I'm not loving it.
Wait, what would you click?
I clicked graph. So when I say I'm guessing the y min and my max, I think I need to be closer because these functions are really small. But do you agree with me? I don't really like the way this looks. I mean, I can see it. I get the vibe, but I want it to look prettier. So I might go from like 0 to 2. Nah, 0 to 2.5, whatever. For a y. So the x is given to me. I'm just trying to make a prettier picture right now. It doesn't really matter.
Yeah, mine weren't curved at all.
All right, so they're a little more curvy, and I can see that better when I zoom in. So this window is from 0 to pi over 4. in the X direction, and I went from 0 to 2.5 in the Y direction. Those 0 to 2 looks like it will work pretty well as well. Yeah. Can you check your mode? Make sure it's in radians. Yeah, that's actually a really good hint. If your graph, guys, if your graph ever looks like way too flat, it's probably because you're in degrees. All right. Yeah, I know. It's fine. I'll remind you. Yes. My Wyman Max. So I chose 0 and 2.5. So I'm just trying to get it closer so I can see it. Stretching. All right. So all of this calculator stuff has gotten me to the place. That's a good question. So on this test, I'll probably make it mostly calculator. There are some that you would be expected to graph yourself. The next question that we're doing is probably a good example of that. But there's only certain things that you would need to be able to do without a calculator. Yeah, I probably wouldn't expect you to know the graph of secant squared. Sine, yes. You could also plug in some points though to see. So I'm just going to make a quick sketch of this graph. Again, doesn't have to be perfect. I'm just trying to sketch a little bit. So it looks like we start kind of down here, go up this way, start here, go up this way. And this value is pi over 4. So it really, really doesn't matter that much how good our graph is, because the biggest piece of information I need to glean from looking at that graph is which of these graphs is which. I also need to see if they like intersect at more than one place, if they're doing anything funky. But I'm really talking about this kind of bow tie shaped or pasta shaped thing, whatever. I guess I'm hungry. Bow tie is a pasta. It doesn't look like that though. Pulling out the big pasta names. All right. Looking at my graph, the blue one, which was my secant squared, that is the function that is up here. So I'm going to label it on my picture, and then this was sine x. Looking at this guy's blue, so if you go back, it's blue. Also, my knowledge of sine, I know sine goes through the origin, so you could also remember that. All right, so let's set up our integral. We're going to do the top function minus the bottom function to represent this vertical distance between our graphs. So to me, that looks like secant squared minus sine x. Oh yeah, I'm going to draw a bunch of those next time. All right, what is kind of glaringly missing? Bounds. Thoughts on them? Yeah. So some of these questions are going to be really in your face about the bounds. Some of them are going to have to get a bit more creative, like the next one we're doing. This is one of the 2 questions I would like to integrate by hand today, because I don't know if you know your trig derivatives and integrals. Who has a derivative of secant squared? What? Tangent. What is the integral of negative sine x? Regular sine is negative cosine, so I'm gonna do plus cosine. I asked that. Sorry, that was my bad. I asked that question weird. Yeah. All right. Yeah. All right. I'm gonna slap that vertical bar and my bounds on the end to say, hey, I have integrated, but I have not plugged in yet. All right. Let's get out our unit circles. I used to watch this one kid take his test. It was amazing. And anytime he got to trig, his head would pop up and he would start going along with it. It was great. That's what I do too. All right, let's talk. Ready? Do you have your unit circle out? All right. Tangent of pi over 4. Good. All right. Cosine of pi over 4. Rashad. You like, so this is 0 is a pi over 2, and this is like pi over 4, pi over 6, pi over 4, pi over 3, thank you. And you put down whatever finger, so this is your pi over 4 angle, so you got square root of 2 over 2. Wait, is it for sine or cosine?
No, it's one side square root of 2 over 2, and the other side square root.
Oh, yeah.
Wait, I didn't know that.
Oh, I would say I'll relearn it better. Yeah, Mr. Prince knows it really well.
Is he still here?
He's in New Jersey. He went back. Yeah.
Is he?
He had some health issues one year, but he went back home to be closer to family. I miss him. He was so cool. So fun. All right, unit circles back out. Tangent of 0. 0. Cosine of 0. Nice. Anything cool happening? How about the ones cancel? Not cool enough? Okay. It is. Now, let's reflect on this answer for a second, because a lot of this unit, so we're going to be finding areas today, volume next class, and the class after that, and the class after that. A couple of things we need to know. One, this is actual area, so not signed area anymore. So if you get a negative answer, you did it wrong. I know this is above the x-axis, but even if it were below, we're actually finding area now, so you should not get a negative answer. If you do get a negative answer, probably what happened was you flipped which function should have been the top function and the bottom function. So that would be your first mistake to check. Also, we can get a good idea of how big our thing is supposed to be. So pi over 4, I don't know if you noticed, was about 0.7 something. And this guy went up to like 2 at the top point on the far right corner. So the idea square root of 2 over 2 is somewhere a little bit south of 1. So that seems like a relatively good size. If I got something like 100, I would be a little nervous because this is much smaller than that. So you can get a little bit of a sanity check-in if you don't feel like checking your whole answer. All right, so Rashad asked a good question a second ago of like, will we get a calculator to graph all of these things all the time? This next question is a good example of one where I would be comfortable giving you this without the aid of a graphing calculator, because I believe you should be able to graph these two functions. So anyone, before we graph them, does anyone notice some information that seems to be missing from this question that we had in the last one? Bounds. So as we start graphing, I want you to think of a way we could find them. F of x is 2 minus x squared. What does that look like on the graph? Parabola. It points up or points down? Points down. Where is its y-intercept? All right. What does negative x look like? I don't like the right side of my parabola. Sorry, I'm gonna. It was a little fat. Better? All right. Slope going down to the right. Y-intercept? 0, 0, called the origin. So I'm gonna just kind of sketch this. And I think the area that we're talking about, take a second to actually convince yourself you've got the area that you want. It's a surprisingly difficult step some of the time. Is this kind of leafy guy in here. That guy. So, yeah, so we're going to see these words a lot. Thank you for asking that question, Nina, because I meant to talk about this. The words bounded by, think of it like a fence. So we want the area that's completely enclosed by our two graphs. So bounded by, if you think of this room, we're bounded by the walls, the floor, the ceiling, the door, the window that's open because I wanted to see it snow, but it's not snowing. It was and I missed it. All right. So that's what those graphs, that's what those words bounded by mean. And take a second to think you actually have the right area, because you can really mess yourself up if you're looking at the wrong thing. Anyone have an idea how we're going to investigate those bounds that we were talking about? What do you think graphically I'm looking for? The intersection points. So I could, if I had a calculator, use the calculator to find the intersection points. How can I do that algebraically or by hand? What would I do? That my two functions equal to each other. Wow, you guys just really came with all the answers today. I love it. All right, I'm gonna move everything to the right-hand side because I prefer a positive x squared when I go to factor, but you don't have to. Let's see if I can factor today. Probably not. -2 plus 1. All right, that makes sense because looking at my graph, it looks like the positive intersection is a little bit farther away than the negative. All right, we're going to just set this one up but not evaluate it. Or we can evaluate it on our calculator. I guess that would be fun. Can I use those as a bounds, -1 up to 2? We cool? All right, what is my top function here? F of x. And then bottom function? G of x. I actually really love that you guys said kind of their nicknames, if you will. I would highly encourage you when you're writing down your integrals, if you can write down f of x and g of x, that makes it a lot nicer. I can definitely write down the functions themselves, the actual kind of equation pieces. Just make sure you're using some parentheses because this subtraction sign in the middle does have to distribute to anything on the back end. So you just have to be a little bit careful about notation. Is anyone plugging it in and want to let me steal their number? You got 9? Cool. All right, well, it's going to be a positive number. 6. I was going to say 9 sounds a little big. We'll trust them that it's 6. I don't have my notes in front of me. What if it's not? Do I have to do it? All right, remind me. Rashad wants to work on his problem set, y'all. I'm going to do math 9. I'm going to go from -1 up to 2. No, he's not making it longer. You guys are asking for me to do things. Oh, yeah. And Rashad's getting mad at you.
I'm just disappointed.
I'm going to say you're pulling out the teacher language now. I'm not mad. I'm just 4.5.
I could get plus I knew we did a question.
All right, cool. I was actually a little bit skeptical because I was thinking about the size of this. When he said 9 at first, I was like, that seems a little too big. So cool sanity check. All right, let's keep rolling. We have a few more things to do. Let's get rolling. All right, it's up to you all. All right, here is another example. So from now on, I'm going to be using, I think 3 of the 4 of these are actual AP test questions. So these are all ones from the past few years. This is a good example of how they could get you to not have to use a calculator on the test. So this was a non-calculator question, and this will be the last one we integrate by hand. You can probably see why. If you can't, you should look closer. So on this graph, you'll notice both of my functions are graphed, but they are not labeled. So this is a really good way for them to see if you have enough knowledge to pick out which graph is which without having to like graph the whole thing by hand. So talk to your neighbor for about 10 seconds, and I want you to decide which one is F and which one is G. Okay.
Oh, I think the bottom one is fine.
Yeah. I agree.
Oh, that's actually that's the bottom. Yeah.
All right, we ready? This blue one, who's that? That is the sine one. So if you remember, sine kind of does the wavy thing, but he always comes up out of the origin, like that. So this is our sine pi x. And then the other one is our 8x cubed. If you remember, regular x cubed kind of looks like this guy. So 8x cubed is just going to be got a little bit deeper. They do give us this intersection point, which is nice of them. One thing you want to make sure of, if the intersection point is not labeled, we'll see this in a couple of questions, we have to be a little bit skeptical of it. So essentially don't assume anything because they will get you. All right, so let's do some integrating. What's my integrand going to look like? So my two subtractions, what am I subtracting from what? Okay, I'm gonna actually, since we're gonna integrate this by hand, since it's asking us to find the area, I'm gonna actually use the function's like full name, if you will. Thoughts on bounds? If you need a way, and I'll be telling you a lot of these things because I'm not great with my spatial reasoning, so I'm going to show you all the ways that I help myself with spatial reasoning. This vertical line that I keep drawing, if you take your pen and like slide it back and forth, as far left as you can go should be your bottom bound, as far right as you can go, the x value should be your top bound. That will become a little bit more useful next class when we start doing cross sections and this gets a little bit more complicated. Yeah, love it. They don't have to be. We're actually going to do some y bounds in the next couple of questions. No. If you're using x in your integral, you're going to want your bounds to be x bounds. We're going to do one in a second where y will be in our integral, so then we'll have y bounds. All right. It'll make sense in a second, I promise. All right, why am I asking us to do this integral by hand? This bad boy. What do you guys think about that? U sub. Now, we've been doing a lot of these U subs kind of in our head. Does anyone know what number is going to get chucked out in front of this guy? 1 over pi, because we have the derivative, our du would be pi dx. We don't have that pi, so we're going to chuck a 1 over pi out front. This is a really good option for doing that U sub in our head because I don't particularly want to change my bounds. So I'm going to go 1 over pi in front of just this first term. What's the integral of sine? Negative cosine. Notice that I'm putting that negative not between the 1 over pi and the cosine, so it looks like subtraction, but in front. So it looks like it's being multiplied. All right, thoughts on the integral of 8x cubed? All right, how are we getting 2? Cool. All right, since I've seen people make a mistake on this, which bound goes in first? The top one. Stop putting the bottom one in first, you silly gooses. This is a really gross integral. All right, so let's talk about some things we can do on, yeah, in the middle, yeah. Some thoughts on this. So let's say this were actually the AP test, and I was doing this question. Yeah, you don't have to simplify that. Why would you? That's a waste of time and an invitation to say, hey, reader, take my points away. That being said, if this were a multiple choice question, we might want to know how to simplify it. Anyone know what cosine of pi over 2 is? Pi over 2 is here.
Oh, it is.
It's 0. So this term's going to go away. 0 is going to go away. What is cosine of 0 for here? 1. So I'm going to get, what's 1/2 of the 4? 2, 4, 8, 16. But divided by 2. So this is all going to be negative 1 over 8. That's from 2 over 16. And then plus 1 over pi. Now, one of the good reasons to simplify this is you could do a little bit of a sanity check to make sure, is that number positive? All right, about how big is 1 over pi? About 1/3, which is bigger than 1/8, so that is a positive number. It's going to be pretty small, but that kind of makes sense. If we talk about, there's like kind of a rectangle situation going on. Am I standby? If you look at like this rectangle, that's 1 by 1/2, so we should be getting something pretty small. Again, if you were on the AP test and maybe you're sitting on the free response, you got some extra time, and you wanted to like simplify off to the side and then like scratch it out in case you did it wrong, you could give a little bit of an indication whether you're kind of going in the right direction. All right. Cool. Next question, kind of going back to Nina's question. She said, are the bounds always going to be X bounds? Am I always going to be doing this with X? You don't have to. Sometimes we will do this in terms of Y. So we're going to do it twice. I'm going to show you this first question. We're going to do both in terms of X and in terms of Y. This one's just kind of, you can use whichever one is convenient to you. And then this second one with the Desmos graph that I have made is one where you would want to do it in terms of Y because it makes the problem infinitely easier. So in terms of X, we are still going to be having this situation where our kind of vertical line is rolling up and down because it scrolls along the X values. Let's see if we can set this up. What do you guys think the top function is if I'm doing this in terms of X? Yeah, the Y equals 6, that kind of boring line there. What is my bottom function? 2 root X. Downs now. Thoughts? Top minus bottom. All right, X is still in my integral, 0 to 9. Again, if you want, take your pencil, move it back and forth within your region. We can go all the way from 0 over to 9. We're doing X first. Now we're going to do Y. I just want to compare. Apologies, I'm trying to go fast and I should be explaining more. I don't want to make her sure. No, you're good. What? Yeah. Why are you confused? And we still have X in our integral, so we have to use the X values. All right, so this is setting it up like we did before. What I kind of failed to mention explicitly is we're now going to try to do this one also in terms of Y. This one is kind of equally difficult to do in terms of X and Y, so I want to just show you that. This guy, if we do him in terms of Y, we have to kind of rotate our head 90 degrees to the right. So we're going to be using a horizontal line that will scroll through our Y values, and we have to have our function in terms of Y as well. So while this function is Y equals 2 root X, if I want to think from right to left, I have to get this function in terms of Y. So I'm going to divide by 2 and then square both sides. So I'll get X equals Y squared over 4. One slightly confusing thing about the language that I use, the top minus bottom, is when we kind of rotate our head and think horizontally with rights and lefts. Could you, with your appendages, aka your arms, could you point to the side of the room based on this graph that you think is the top side? Good. So think of like top vertically is like up here, right? The biggest Y values. If we think top horizontally, where are the biggest X values? They're that way. So if you're going to use the language like I use, I sometimes write down top over here. It's like a right minus left. You can think of your number line. You want your biggest numbers minus your smallest numbers. Turn your head this way.
Oh yeah.
Or you can think of like this. Should have had my video on. You can also think of biggest X values minus smallest X values. So this X value might be like 5. This one's like 0. You want to make sure that distance is positive. So you would want to subtract right minus left. Lots of different ways to think about it. But numerically, if you think like on a number line, you want to go from the bigger values to the smaller values. Yeah, Kat. Yes. So Kat's noticing something pretty cool. Would you guys agree with me that our top function is the Y squared over 4? What Kat's noticing is the Y equals 6 is not in the case of in terms of y is not going to be functioning as our top or bottom function. The y-axis is actually going to be functioning as my bottom function. So if I were to subtract something, what would I subtract? 0. Now, technically, this is just like a straight up integral since I'm going back to the y-axis. So you don't necessarily have to subtract 0. I like subtracting 0 in a lot of places in this unit to remind me to do things. So if that's starting to annoy you already, you do you, man. All right. I'm going to do dy at the end because I have y's in my integral. And here's where Nina's question really comes into play. I need to use y values as my bounds. So what will my bounds now be in this question? 0 to 6. So that's where the y equals 6 comes back in, is it's going to cut off my area at the top. So if you have this on paper, honestly, I like to like rotate it and look at it. Yeah, that's fair. Ashley, what's up? So in this one, I was just kind of showing you that you can do some of them both ways. So if this were a question on the test, you wouldn't. You could choose one of the ways. And if we integrated these on the calculator, each one of these would give me the same exact number, which actually provides a pretty good segue into the next question. So thank you. Some questions are going to be much easier to do in terms of y than in terms of x. I'd like to demonstrate with this picture. Do you guys want to? All right, really quick. Amelia's table, Rashad's table, ladies in the back, can you integrate the x one? Everyone else integrate the y one. You can use x as your variable if you'd like. Yes. Press math 9. You guys are doing 0 to 6. You can use x once you type it in. So x squared over 4 alpha y equals and enter. If you really wanted to.
Oh my God.
If you want, you can use the calculator or you can do it by hand, either one. Claim is 18. Let's see it. They should. All right, anyone doing the X one? Did you get 18?
I got 17.999.
Okay, that's your calculator being bad at saying 18, but yeah, it approximates. All right, so the X side, they got 18 with some calculator dumbness. And Y side got 18. You should be able to set it up both ways. So if you're really aggressive with checking your answers on the test, set it up both ways. I would like to look at this next question, though, specifically with this graph. There's a couple of reasons why in this question it is much more beneficial to use in terms of Y. First reason, if I look at the graph and I start trying to draw that vertical line that I've been doing, oh my gosh, a reunion in the bathroom. Oh, I yelled at some people earlier. Yes. I said, it's something to the effect of get back to class. I don't think so. I don't think I was very creative. I was trying to finish up some stuff. All right, if you notice, this line on the left-hand side, that line has a pretty consistent top and bottom function. We've got the blue one on the top, the red one on the bottom. Notice after we shift past that kind of intersection point at the top where the blue and the red lines meet, we change to having the red one be the top and the red one be the bottom. So if I were going to do this in terms of x, I would need 2 integrals. That sucks. I don't want to do it. If instead I orient my line horizontally, notice that no matter how far up I go or how far down I go, I have the red graph to the right and the blue graph to the left. So graphically, it looks easier to do the in terms of y. Also, look at our functions. Do we normally get functions that are in x equals form? No. So the person who wrote this question is trying to tell us, hey, maybe, you don't have to, but maybe might be a good idea to use y's in my question. Does anyone know, without using your calculator, which graph is which here? All right, 3 minus y squared is the parabola. The switching the x and y is going to make it so it's that sideways parabola, and this is our y plus 1. So let's see if we can set this up in terms of y. All right, what would you guys consider my top function here? The 3 minus y squared. If you want to add some verbiage, you could say right minus left. No, so we don't have to do anything like we did up here because they gave us our graphs in terms of y already. Good question. Minus, and here we need to do our y plus 1. Notice that these parentheses are super important so that we make sure we're subtracting that 1 as well. Those often get dropped when we put things into our calculator, so just be careful. Thoughts on bounds? All right, first question, as we look for our bounds, should they be x values or y values? Y values. So what's the lowest we can go? -2, this guy down here. What's the highest we can go? 1. And reminder, you need to stay in your region. So if you're looking, when I say how high can I go, notice this shaded region only goes up to 1 and the shaded region only goes down to -2. So sorry if I was not clear with my questioning there. Like I said before, once you plug this into the calculator, it does not matter what letter you use. So you don't have to use like alpha y in the calculator. You can use whatever you want. Let's just all plug it in and make sure that we all get the same thing. Someone do math 9. Wow. Drama. Yes. Oh, wow. I was really not creative with these questions. Perfect. Yeah. It always breaks my heart a little bit when everyone sets it up perfectly on the test, but then the number doesn't match the answer, and I have to highlight just the number. Because then you have to plug the whole thing back in.
Wait, why did you do -1?
So I forgot my parentheses. So I just decided to, in my head, distribute this negative sign. Yeah. I had the math to back it up, though. So I'm going to call this 9/2. I just felt like doing a fraction, just mix it up. All right, the last question we're going to do is kind of the weirdest one, but it's the most calculator dependent. It's not going to be very hard. We just have to finish this up, and then you'll have almost 45 minutes to work on your problem set. All right, so this is a relatively recent one off of the AP test. I think this is from the 2010s. So we've done this recently. I want to say 2015. So you're welcome. Sometimes these are free response questions that have like all to do with Unit 7. If that's the case, we may have A, B, and C that all have to do with the functions f of x and g of x. My recommendation in that case is to immediately go and put f of x in y1 and g of x in y2. You'll notice for this is definitely a calculator question. The functions are not nice. So remember the lovely words of Ms. Kaczmarski, if you are integrating by hand or taking a derivative by hand on the calculator section, you're doing it wrong. Specifically for this one, you don't know, and I don't know how to integrate that guy, the e to the x squared minus 2x, so you gotta use your calculator. This is not like the SAT optional version. Yeah. Because you don't have the du near it at all. You need a 2x minus 2. Hey, Jekka.
So that's what you mean by like, you say that we would do it integrated.
Yeah. Yeah. So You did the X squared. Mm-hmm. That's a good question. Let me finish plugging these in, and then we'll talk about it.
So we just finished the notes and like a couple minutes. Watch the recording.
Oh, no. I hate this function. 6.5x squared.
Like what we see on the calculator.
Not really. All right, so I'm going to answer a couple of questions that I got while I was plugging mine in. They were both very good questions. First question was from Hannah. She said, do we really have to plug these into the calculator, like to Y1 and Y2? The reason that I'm definitely doing that, hey, Nate, is did they label this intersection point in the middle? No. What do you think everyone's going to say that intersection point is at? What X value? 1. They're going to say it's at 1. It's not. It's at like 1.0 something. So we're going to have to find that intersection point using our calculator. I'm going to do that on the graph, which is why I'm putting it in Y1 and Y2. Why am I getting a million text messages? I am not. Like 3 friends. All right.
We are true.
You guys are high schoolers. You guys want to be my friend? I'm old and weird. All right. So, will you go up to where it says plot 1, plot 2, plot 3, and push enter until they're not highlighted? Correct. Yes. All right. So I'm going to need to find that intersection. Someone over here asked a question too. What was the question? Will you remind me what it was? Because I wanted to answer it for the class. Oh, right. So do I need to change? Oh, I need to change it from this. So I don't want to change it from the standard one. I don't really need to there, but I would like to at least see what's going on. So I'm going to press Zoom 6 just to get back to the standard window. Yeah, Zoom 6 is really great if you get zoomed all weird. So I don't really need to like zoom in till it's perfect like it's on the picture, because really I'm mostly concerned with that intersection point. And this is one of the very few skills that I need to be able to do on the calculator is find intersection points. So I'd like to review how to do that if we've done it before, or teach you how to do that if you haven't done that before. Yeah, it is in the second trace menu again, or the second calc menu. This is basically where anything you need would be on the graph. And I'm going to go to number 5 for intersection. It's going to give me 3 prompts, a first curve, second curve, and a guess. If you only have 2 functions graphed, you can kind of enter through the first 2 of those because it's just the first curve and the second curve. For the guess, you need to be closest with your little cursor to where your intersection point is that you need, or you need to provide an actual guess. So I could scroll to the right until I'm closer, or I thought it was at about 1, so I could press 1 and then enter. Notice that intersection point is a little bit off from the number 1, and I'm guessing that if I use 1, not only would my notation be wrong, but I'm pretty sure my answer is going to be wrong as well. Now, I would love, though, to not have to write that number down all of the time. So I'm actually going to store this number in my calculator, a really cool thing to do. So without changing anything on my graph, I'm going to press second quit to get to the home screen. Notice if I push X right now, it has that number stored for me. But if I change anything about the graph or try to use X in my integral, it's going to get confused. So I would like to tell my calculator to take that X value and store it as a different letter. I'm going to choose capital A, which is alpha, and then the math button, and then I'm going to press enter. What this is going to do is it's going to store that value as A until I change it. So I would have to physically change the A value for that value to not be stored anymore. But notice if I go back to the graph and I move this around, if I go back to the main screen, the X is now different.
But the A is
The A will still be the same. So I have to physically either clear the memory or change the A value myself to change that.
Is the X
Yeah. Yeah, Sean. Wait, what? Oh, store is right above on. It says stove. All right. So a couple of things I'm going to do. I would like to also be a little lazy on my paper. So what I'm going to do is I'm going to write down this decimal, 03283. All right, if I label that on my paper as my A value, not only will I not forget what value I put it in the calculator as, but now that I've labeled it on my paper, I could use A in an integral if I would like to. Now, we have this intersection point. I didn't really talk about why we needed the intersection point. Does anyone see why we're going to need that intersection point? All right, we're going to need it for bounds. Why will I need it for the bounds? Why can't I just go all the way from 0 to 2? All right, I've got two separate areas. And what I do notice is that a different function is the top function in R than is the top function in S. Anyone know which function is which, by the way?
Oh, 1 plus X plus e to the X to the bottom.
In R?
Yeah.
Yeah. So this guy's f of X here, but f of X over here, g of X here, g of X here. I could use my calculator to verify that. So I'm going to show you two ways to set up this integral. The first one is going to work all the time, even if I had to integrate this by hand. The second one will only work if I have a calculator. So first way, I'm going to start by integrating from 0 to my shortcut guy A, g of X minus f of X, top minus bottom. To that, I'm going to add the area. Notice it has the sum of the areas from A to 2 of f minus g. Here, I would highly encourage using f of X and g of X instead of their full names, because odds are you're going to write something wrong. All right, there's another option if you have a calculator, and that's the one I'm going to actually plug into the calculator. It's a little bit shorter. So our subtraction is this vertical distance between the graphs, right? What do you think would happen if we subtracted the wrong way? You get exactly the negative of what you want, right? So do we have a function that takes negative things and makes them positive? So other option, if you have a calculator, I could disregard that intersection point totally and say, I'm going to go all the way from 0 to 2, and I'm going to make sure you're positive. And in this case, it doesn't matter which direction you subtract. So I'm just going to do f of X minus g of X, but g of X minus f of X would work just as well. Now, remember, absolute value does not play well with calculus. So this one only if you have a calculator, because I can't just integrate those functions inside the absolute value and do it. I have to use a lot of like piecewise stuff, and it gets really gross. All right, last thing I want to do is just show you guys and remind you guys how to reference functions in the calculator, and we're going to sanity check our answer. I'm going to plug in the absolute value one just because it's a little harder to plug in the calculator. So I'm going to do math 9 for my integral. Where are we going from 0 to 2? All right. Anyone remember where the absolute value bars are? All right, what class are you in? Be less specific. Math, there we go. We're in math. We're going to go over to num, and we've got abs. There's a different way to get to it. That's the way I do. It's in one of the alpha menus. Now, this is the important part. I would like to reference y1 and y2 so that I don't have to go back and get to them. So I'm going to press alpha and trace, and notice I get a list of all the functions. So I'm going to do y1 minus alpha trace y2. That is just a great trick to be able to do. It saves you a heck ton of time for typing and the possibility of a lot of typos. especially if this free response had been like multiple parts with the same functions. If I just really concentrate on plugging them in the first time, then we're good to go. It does take a little bit of time for that to integrate because we're asking it to do a lot. Two pretty confusing functions, absolute value bars, and some calculus. So be patient with it. What's the answer I'm going to write down? Good. 3 decimal places. So we're ending with that 4 here. It doesn't matter whether we truncate or round, but you can do either with one that it matters. So I get 2.004. Things I like about this answer, it is positive. Also, seems to be a relatively good value. We're only going between 0 and 2 xy's, and it didn't look that big on my graph, so I'm feeling pretty good about it. All right. It's not, yeah, there's like, no, what is this? Everyone's like, we should get out early in my last vlog. Climate change. All right. So I'm going to do a couple of announcements really quick and just tell you what the rest of the block is going to look like. It's currently 1:54. We get out of here at 2:28. Before you leave, I would like your problem set. Things that you can do to work on your problem set. You can talk to each other, but the minute I see you copying off of someone else's paper, both your paper and their paper go in the recycling bin. Also, the next time I see you, what's happening? Test. The answer key and the review are posted on Schoology. I'm going to take a second to post them on OneNote as well if you're more of a OneNote person. I think that answer key is good. I did it this morning. Apologize for the delay. It's been a busy week. If you think you see any mistakes, shoot me an email. I'll check over it one more time. But it's a pretty gnarly review. I will say I'm going to try to make the test questions either at or easier than the questions you've been working on. So a lot of the questions in the problem set have had like a lot of U subs. I'm going to kind of try to minimize that when you're working with other methods. Next class after that, we'll be working on volumes by cross sections. If you're interested, I'm going to put some pictures up on the board of what that looks like. You guys have about 32 minutes. Best of luck. Yes.
Am I free to go?
Yeah, Nate, if you want to head out, you're good.
Okay. Can I email you the problem set later today?
Yeah, if you want to turn in later today, that's fine. Or Nate, if you just want to bring it when you come back to school, that's also fine.
Okay.
Do you have an ETA of when you're coming back to school?
We get back Wednesday, right? I'll be back Wednesday.
Perfect. Yeah, just bring it then. Don't worry about emailing it.
Okay, thank you.
See you, Nate.
Bye, Nate.
Yeah.
Like a little phone call.
Yeah. I'm glad we got